Hello Canners. This video goes through the inner workings of the most critical pieces of CanJS, how its key value observables and computes work. Before we get into it, a quick disclaimer. The code I'll be showing is very similar to how CanJS's code actually works, but it differs stylistically. Watching this video will give you a very good picture of what's going on, but some methods have been renamed or simplified to make things easier to follow. With that being said, let's show what we're actually building. SimpleMap is mostly just a simplified version of CanMap, the newer DefineMap, and the newer still CanObserve. We are going to see what it takes to build CanJS's SimpleMap and observation constructor functions. They all work pretty similar under the hood. We can create a simple map with new SimpleMap and read its properties with get and set them with set. Observation is used to build computed values from other observables. We can build a full name observable from the me first and last properties. If we read full name, we will get back what is returned by the function passed to new observation. Now, full name might look like a normal function, but its real power is that it's observable. We can listen to when full name changes by calling on and passing it a callback handler. When we change any of full name's source observables, in this case me's first property, the change handler will be fired. This is what we are going to be building, a simple map and an observation. But in order to build them, we will also be building a tree library and a queue library. So to build it all, we are going to start by building a rough version of SimpleMap's get and set and on methods. We'll then learn about keytree and see how trees help us organize event handlers, improving the on method in the process. Next, we'll begin implementing a rough version of observations get and on. We'll learn some new features of keytree and use these features to make it so observations only set themselves up the first time they are bound to. Then we are going to learn about how observation recorder informs observation about observable values being read. We'll do that informing in SimpleMap's get. We'll also implement observations onBound setup code and what it does when a dependency changes an onDependencyChange using the information from observation recorder. At this point, we'll have a rough version of SimpleMap and observation, but we'll go over some problems that make the solution less than ideal and requires us to use queues. We'll then use queues to re-implement many of these methods over again. SimpleMap set and on, followed by observations onBound and onDependencyChange. At this point, we'll have something extremely close to how CanJS works. We'll finish the presentation by recapping how all of this works with the example from the beginning. If you've had a hard time understanding this presentation, this part should hopefully put it together for you. So let's start by implementing SimpleMap's get and set. This shows how you can create a simple map and use its get and set methods to read and write properties. We can implement this fairly easily by storing the data for a simple map in a data object. Get and set just read and write values from and to the internal data object. Now let's implement on. On lets you listen to when an individual property changes. This shows listening to first. When first is set, the first handler is called with a new value. To implement on, we'll store a handlers object on each map. On will add handlers to the handlers object inside arrays organized by the property name or key someone used to register the handler. Notice this code checks if an array of handlers does not exist for the key. If it doesn't, an array is created. Then the handler is added to the handlers array for that key. To fire handlers, we change set to loop through the handlers for the key being changed and call each handler for that key. If we graphed how handler functions are organized within the handlers object, we can see that they look like a tree. Notice how the handlers object has branches organized by property name, and those branches are arrays of function callback handlers. CanJS's CanKeyTree package is used to organize values in trees. We use it to organize handlers on observables like SimpleMap. In the example above, it shows creating a key tree and adding values to it. Notice that we create the key tree with an array of constructor functions. This specifies how to create the nodes in the tree. By object array, we want the root of the tree to be an object and the next nodes to be arrays. When we add values to the tree, we specify the path and values. After adding Chicago, Rockford, and Los Angeles, the tree structure looks as shown here, an object with Illinois and California properties with their corresponding array of values. KeyTree also has methods letting us get and delete nodes in the tree. So now let's rewrite SimpleMap to use KeyTree, first by changing handlers to a tree. Then changing on to add handlers to the tree, and finally changing set to get the handlers for the key and calling the handlers with the new and old value. Now that we've created a basic observable, let's start making an observation. As a reminder, observations take a function that determines their value. That value can be retrieved by calling get. Notice here that an onBound observation calculates its value each time it's read. When the observation is bound, it will calculate, aka compute, its value and cache it. When the observation is read from that point forward, the cached value is used. To begin building the observation constructor, we'll make it take and save the evaluator function. We'll also create a tree of handlers. While this could be a plain array right now, later we'll want it to be a tree, so we'll start with a tree right now. We'll implement get to test if the observation has been bound. If it has, we'll return a cached value. Otherwise, we will return the result of the evaluator function. Finally, we'll implement on to store the handler, set bound to true, and run the evaluator to store the cached value. This implementation leaves two problems. First, if on is called multiple times, we don't want to rerun the evaluator function. On the first bind, we should calculate the value and keep it, but not on the second, third, and fourth, and fifth, and so on. Second, we want to rerun the evaluator function when observables read by the evaluator function change. Let's solve the first problem first. Fortunately, the first problem is solved easily by KeyTree. When creating a key tree, you can provide callbacks when the tree contains its first node and when the tree becomes empty. Here we've made it simply log when these happen. Notice that as I add Chicago, onFirst is logged, and when all nodes are removed by delete, onEmpty is logged. So we can use this feature of KeyTree to cache the evaluator result when the observation is bound for the first time. We make the handlers KeyTree call onBound when the first handler has been added to the tree. In onBound, we can cache the value. Now this leaves the remaining problem. How can we reevaluate the cached value when observables read by the evaluator function change? Somehow, we need to know which observable values are read by the evaluator function. To solve this problem, CanJS uses a singleton module called Observation Recorder. It can be used to capture observable values read between its start and stop method. When observables in CanJS, like SimpleMap, are read, they call Observation Recorder add to register how to listen to changes in the observed value. Observation calls start before running its evaluator and stop after its evaluator to get the results of Observation Recorder add calls. The result of calling stop looks like an object containing the objects to observe and the event names to listen to. For example, this observation record says to listen to person's first and last properties. So first, we need to change SimpleMaps.get to inform observation that an observable key value is being read. And second, when the observation cached value is retrieved, we call observation recorder start before calling the evaluator and stop after the evaluator. Record has a list of observables and the events we need to listen to. So now we know the observables we need to listen to for changes to know when to update the cached value. We can loop through all of those objects and listen to each one's events. This is where we bind on the simple maps first and last events. Notice we call onDependencyChange when any dependency changes. When a dependency changes, we will repeat what onBound did to get a new cached value and bind on any new dependencies. Then, if the new cached value is different from the old cached value, we will call all the handlers registered on the observation. Okay, so now we have a reasonably working simple map and observation. These were pretty much akin to CanJS 1.0's technology. However, there's some subtle problems in this naive solution. The most important one is determinism. In this solution, it can be difficult to know what value you might get if you read an observable value while observations are still updating. We can see this in a slight variation of the initial example. Notice in this example, it binds to me.first directly, and it binds to full name like before. When we change the value of me's first key, me's first handler is going to be run first. If that handler reads full name, it will get full name's cached value. This is because the onDependencyChange handler that full name registered is bound after the me first handler. When full name eventually sees first changing, it will reevaluate, updating its cached value and calling the full name event handler. The problem here is that you might read a value but not get a result that is consistent with the actual state of the application. That's bad. Another problem is that we might recalculate unnecessarily. Let's say we wanted to change two properties on the me object at one time, similar to a transaction. Currently, when the first property is set, we will recalculate full name and call the full name handler with an intermediate value. Then, when the last property is set, full name will again be recalculated and the full name handler will be called with the final value. While we aren't going into this today, the queues solution we are going to explore allows CanJS the ability to wrap multiple changes in a batch. When the batch is stopped, all events are dispatched. The full name observation will only be recalculated once, and the full name handler will only be called back with the final value. So what is this magic solution to all of our problems? It's queues! CanJS has a queuing system that allows one to register functions to be called only at a particular time. CanJS has 4 queues, a notify, derive, DOM-UI, and mutate queue that run one after the other. This means that all notify functions run before any derive functions and so on. Let's see how we'd want the previous code to run with respect to queues. What we'd want is instead of the first handler being called immediately, we'd actually want it to be called when all values have had time to update. This means that all event handler callbacks should happen after everything else. In CanJS, all user event handlers are run in the mutate queue. This makes it so full name get will give the right result. The observation should update itself before the mutate queue. In CanJS, this happens in the derive queue. Finally, changing a property needs to tell all observations that something has happened. This will happen in the notify queue. By the way, if this isn't making a lot of sense right now, don't worry. It will by the end of the presentation. But first, some background on queues. In CanJS, there's a queues object that contains the different queues you can enqueue a task onto. Tasks are just functions with a context and arguments. For example, if you wanted to run console log to print say hi, you could enqueue it in the notify queue shown here. Then, to run all tasks in the notify queue, you call flush. To implement a queue is relatively straightforward. You keep a list of tasks and a cursor to the next task that needs to be flushed. And queue adds the function, its context, and its arguments to the task array. Flush walks through the list of tasks, incrementing the cursor and calling each task. When there are no more tasks, the counter and list of tasks are reset. The CanQueues package in CanJS contains several of these queues and wires them up to flush one queue after a previous queue has completed. It also has this enqueueByQueue helper function to enqueue several functions at once and begin flushing the queues. We will be using this to run SimpleMap and Observations event handlers. Okay, so the first thing we want to change is to make observations update their value in the notify queue. We're going to do this by passing the name of the queue we want the onDependencyChange handler to run in to the underlying observables on method. So here, when we listen to a source observable change, we are saying, let us know the change happened in the notify queue. Now we've got to make SimpleMap respect this queue argument. To make SimpleMap respect this queue argument, we need to make SimpleMap organize handlers by key, then queue. For example, we might want to register a first callback in the mutate queue and another first callback in the notify queue. So we'll change the key tree to make this possible. Now, when a handler is added via on, it will include a queue name. We will include the queue in the path we add registered handlers. Finally, we need to run the handlers in the right queue. So instead of getting all handlers and running them right away, we will use the enqueueByQueue helper to get all handler functions and run them in their particular queue. Handler's get node returns an object that matches exactly what enqueueByQueue is expecting, functions organized by queue name. So now that we've made SimpleMap call its handlers in the right queue, let's return to observation to continue making it work with queues. Now we last left observation after we bound its onDependencyChange handler within the notify queue. Instead of reevaluating the observation's value in the notify queue, we want to instead defer that until all notifications have been fired. We'll change onDependencyChange to enqueue the observations update method in the derive queue. CanJS's derive queue only allows a function to be enqueued once. This means that if an observation receives multiple notifications, only a single update is performed. For example, if first and last change within a batch, update would run only once. Finally, we enqueue the observation's event handlers within their appropriate queue. Yeah, we did it! We implemented a basic version of SimpleMap on observation. But if you're left scratching your head, that's okay. Let's walk through an example to hopefully cement this concept in your mind brain. This is the same example from the beginning, but with a me first event handler. Remember, in this handler, we should be able to read the full name observation and get its updated value. Let's walk through what happens line by line. After creating the me SimpleMap, we are going to register the first event handler. This will get added within me's handlers tree shown in this graph. Notice this handler is added to first's mutate branch. Next, the observation is going to be created, but nothing really happens there. But when full name on is called, that handler is going to be saved within the full name handler's key tree. As that is the first handler in the tree, observations onBound is going to be called. This is going to run the evaluator function and see what observables were read. It's then going to bind on those observables. Notice we add onDependencyChange to first and last's notify branches. Now comes the time when things start to make use of queues. We've listed them at the bottom of the screen. When set is called, it will enqueue all handlers for that key. The first branch has two handlers. First, it has the full name observations on dependency change notify handler that will be enqueued in the notify queue. Second, there's the mutate handler listening to first changes. We added both of those functions in the respective queues at the bottom of the screen. Once the functions are enqueued, the queuing system runs the first function it finds. In this case, it's the full name observations on dependency change function. The onDependencyChange function simply enqueues the observations update function in the derive queue. Again, the queuing system is going to run the first function it finds. In this case, it's the update function. The update function reruns the evaluator function, caches the result, and if the result is different, enqueues handlers on the observation. The full name observation has a mutate handler. This will be added to the mutate queue. Again, the queuing system is going to run the first function it finds. In this case, it's the first callback handler. When the function runs, first will be Ramya, but we can read full name get because the observation updated itself in the derive queue. And then after the first handler ran, the queuing system is going to again look to run the first function it finds. In this case, it's going to be the callback for full name. The full name callback will be run, and the new value will be Ramya Meyer. Finally, the task queue will be empty and nothing else happens. Hey everybody, thanks for watching. If you want to learn more about key tree, queues, and observation, I've put links to in-depth videos below. And if you like these under the hood videos like this one, please make sure to like and subscribe and/or leave a comment.